Hi everyone, and welcome to this third episode on the Mandlbaur insanity. I guess it is no longer necessary to introduce John, the guy who has two neurons that are both fighting for the third place. So, let us move on to today's topic. The guy is now claiming that Newton's laws are wrong. Yes, you heard well, and since the guy is a liar, let me prove that he really said that in case he tries to deny it. The point is that he keeps harassing me by sending me messages. I could block him, of course, but it is not in my nature to flee. So, here is a proof of what he said. You can see that this is an actual Twitter chat box and not some screenshot that I could have photoshopped. Okay. So, there are three laws, and today we are going to experimentally test the first one. So, the law states that an object at rest will remain at rest, and an object moving will keep moving at constant velocity unless acted on by an external force. So, to test the law, we need an object with no net force being applied to it. We can obtain a good approximation of such a system by using a cart that rolls on a track with very low friction and very low air drag. There is surely a non-negligible force acting on it. It is the weight, but it is exactly compensated by the track's reaction force. How do we know it? Simply because if that wasn't the case, either the cart would sink into the track or it would take off on its own. So, the net force is just the air drag, which is very small at low speed, and the rolling friction, which is also very small in comparison with the inertia of the cart. Here is the real thing. The cart rolls very well on the track, and I added some masses onto it in order to give it a lot of inertia. So, let us test the first part of the law. When the cart is at rest, it should remain at rest. Let us wait a few seconds. Yep, it looks like it stays at rest. What about if it is initially moving? Then we would have to test whether its velocity remains constant or not, and for this I installed a motion detector so that the computer can record the speed. For convenience, the recording software includes a trigger, so all I have to do is to give it a push and catch it before it crashes into the detector. And as you can see, the computer collected some data. So let us get a closer look at these data. The upper graph shows the distance between the detector and the cart as a function of time. And it decreases as one could expect since the cart was moving towards the detector. The lower graph shows the velocity, and as you can see, it is nearly constant. So this experiment supports the validity of Newton's first law. If you want to claim that it is wrong, Mr. John Mandlbaur, you have to do an experiment that proves it wrong. Just saying that it's wrong is not enough.